So in today's class, let us move for the deletion process of binary search tree, right? So how the deletion process takes place with respect to binary search tree. So in the previous lecture, we have seen the searching operation and insertion operation. Okay, so now let us move for deletion. We will discuss what is meant by deletion operation first and what are the different cases available with the deletion. One by one we will discuss, right? Then we will move for an example. Okay, we will take one example, and for all the three cases, let us solve the example for this deletion, and then we'll see one overall example we will discuss. Okay, so this is what we are going to discuss in today's class. So first, what is meant by deletion? Okay, so since already we have performed this operation with stack, queue, okay, in linked list also we have deleted some nodes. Okay, so the deletion process already we performed in several places. Okay, so deletion operation is performed to delete a particular element from the binary search tree. Okay, so whenever an element needs to be deleted from the binary search tree, here we will be moving for the deletion operation. Okay, and just like that, we cannot delete an element from the binary search tree. Why? Because the tree has been constructed by following certain BST properties. Right, so while performing the deletion, we need to satisfy that BST property also, and at the same time the structure of the tree also should be rearranged, right? So all these things are there behind performing the deletion process. Okay, so first we will see what are the different cases we have with the deletion. So deleting a node has three cases. Okay, so the first one is deletion of a node having no child, okay, which means the leaf node deletion we are going to perform. So whenever we are planning to delete an element, if that particular element is a child node, okay, then how the deletion process takes place. So remove the leaf node that is to be deleted from the tree directly. We don't have any further procedure for performing deletion of a leaf node, right? So that is the first case, simple deletion operation. Then secondly, we have deletion of a node having only one child. Okay, so a node is the node which we are going to delete. It is a parent node and it has only one child node. Okay, then how we are going to perform the deletion? The parent node will be deleted and the child node will be connected with its grandparent directly. Okay, that is case 2. Then we have last case, deletion of a node having two children. Okay, so deleting a node which has two children. So the node which we are going to delete is a parent node and it has two branches, which means two child it has. Okay, then how the deletion process takes place? So if it is case 3, right, deletion of a node having two children, right, then again it will fall under two subcategories. So the first one is type 1. So visit the right subtree of the deleting node. Okay, the node which we are going to delete, its right subtree will be visited. Okay, select the least value element called as in order successor. So in the next slide, I will show you the example for this. Okay, so whenever we are going to perform deletion of a particular node, okay, if we are going to perform the deletion from the right subtree, right, then what we need to do, we need to identify the least value element called as in order successor. So which element will come next to this particular element? Okay, so the element which we are going to delete, after this element, which element is the successor for this? Okay, so that particular element will become the parent node now. Okay, after deleting this current element, in this place the next successor element will be replaced. Okay, then replace the deleting element with its in order successor. So these are the three steps we are going to follow under type 1. Okay, then if it is type 2, okay, then visit the left subtree of the deleting node. So for the deleting node, you just go for the left subtree, select the greatest value element called as in order predecessor. Okay, so the node which we are going to delete, if it is a parent node, okay, so it obviously its left subtree will be holding the value lesser than this particular node. Okay, then from the left subtree we need to find out the element which is largest among all the elements. Okay, so if you go for in order traversal, it will be the predecessor, in order predecessor. Okay, So replace the deleting element with its in-order predecessor. Right? So replace the deleting element with its in-order predecessor. So these are the 3 steps we need to take care when it falls under type 2. So type 1 we will be performing with right subtree, and type 2 we will be performing with left subtree. So these are the 3 cases which falls under deletion operation. So whenever deletion occurs, we need to check which particular node we are going to delete. If it is a leaf node, simply the node can be deleted, no other problem, right? If it is a node which has one child, okay, so if it is a parent node, if it has one child, then the parent node will be deleted. The child node will be connected with its grandparent. Okay, the third case is deletion of a node having 2 children, right? So then we will be having type 1 and type 2 deletion. Okay, so now let us discuss what are those 3 cases we have, okay, with example. So case 1 is when deleting a node if it is a leaf node, okay, when deletion takes place with leaf node. So just see this example which I have taken here. So I have element 4 and 5, right? So as per the binary search tree property, the parent node is having value lesser than its right child, right? So element 5 I have as a right child. So what I'm going to do here, in this case I'm going to delete element 5, right? So since element 5 is a leaf node, directly we can go for deletion operation. Okay, so you just see here, simply I have deleted element 5 and remaining I have element 4. Okay, then the case 2 is when it has one subtree, either left or right subtree. Okay, deleting a node with one child node. Okay, so the child node may be a left child or it may be a right child. So in this case, you just see I have a element, I have a BST like node 6 connected with 9, okay, and node 9 connected with 8. So in this case, I am planning to delete element 9. Okay, so what is this element 9? Element 9 is having one child node which is 8. Okay, when it is a single child node, if it has, then simply we can delete this node and the child node will be connected with the grandparent. Okay, so remember in the beginning, in the introduction lecture itself, we have discussed that this is a child node, right? So element 8 is a child node, element 9 is a parent node, element 6 is a grandparent for element 8. Whereas 6 is a parent node for node 9, right? And it is a grandparent node for node 8. Okay, so here the child node will be connected directly with the grandparent. Okay, so that we can delete a node which is having a single child. It may be a left child or it may be a right child. No other problem, right? Since we have only one child node, no need to perform any comparison. Simply we can make this node to come here. Okay, so this is about case 2. Then we have case 3. Okay, so in case 3, when it has both left or right subtree. Okay, when we are going to perform deletion, we are going to delete a node. While performing deletion, if that particular node has 2 child nodes, if it has 2 branches, then how the deletion takes place. Okay, so in this case, we are going to perform deletion with node 9. Okay, the node 9 is having 2 branches. It has 2 child nodes. Okay, so in this case, node 9 is present in the right subtree. Okay, so whenever it is a right subtree, so it falls under type 1. Okay, deletion of a node having 2 children, type 1. Visit the right subtree of the deleting node. Select the least value element called as in order successor. Okay, so in this case, we have a right subtree. We have the node 9 which we are going to delete. Okay, so we need to check its right subtree. The node which we are going to delete traverse through the right subtree of that particular node. So in this case, its right subtree is having only one node. Okay, so in some other cases, we may have multiple nodes here. Okay, in this case, we have only one node in the right subtree. Okay, from the right subtree, we need to take the in order successor, least value. Okay, so remember, if it is right subtree, we need to identify the least value element. If it is left subtree, we need to identify the greatest value element. Okay, so in this case, see, in this overall tree, after node 9, node 12 will occur. Okay, so hence delete this node 9 and make this node 12 to be a parent for node 8, like this, right? So this is the case when the deleting node has both left or right subtree. Okay, when it has both, then we need to perform deletion like this. So before performing the deletion, we need to replace some element in this place, right, in the deleted place. So for that we are following the condition. Okay, if it is right subtree, it has another condition. If it is left subtree, it has some 3 rules. Okay, so like this we are going to perform deletion with case 3. Okay, I hope this is clear. See, case 1 and case 2 will be easier. So why? Because in case 1, the node which we are going to delete will be a leaf node. Okay, if it is case 2, the node which we are going to delete will have only single node. So no problem, right? So simply we can connect a child node with the grandparent, right? But in the case of case 3, we have the element which we are going to delete will be having 2 subtrees. So there we need to follow those 2 types also.